I'm going to pass around a sheet of paper like this. It's a kind of a heavier cardstock. What I'd like for you to do is fold it. If you can, try and fold it into 3 sections like this. Doesn't have to be perfect. Okay? You get the idea? And then what you're going to do, so I'm going to pass around some markers. You're going to write your name on it. Like that. And then you're going to set it on your desk like that, facing me. And then I can call on you. Sound like fun? You did?
Yeah, only we got to decorate them.
Oh, well, you can draw a little smiley face or something on there. You'll share that marker, please. There's a marker. So we're doing a fun activity, an art project here to start class. There's a marker. Are you comfortable on that side? You want to be on this side? You're all right there? Here, you can use that marker. I have extra paper in case you're having trouble with the origami part of the assignment here.
It's just that first name, right?
Just your first name. You're fine.
Yeah, I did all of them right. All the other ones, it's just like, if you like wrote what he says, like,
And we'll get started. Any questions on the homework? Okay, go ahead, Jennifer. Jen? What is it?
number 12 on the proportions.
On proportions from the homework, number 12. 95 male students, something like that? Okay, you know what, before I actually begin, let me just remind you that exam 1 is going to be next Tuesday. And I'm gonna do this exam for the entire class period, so we're not gonna, meet, take a test, and then everyone stays around and then we do lecture afterwards. So I'm going to give you, I guess, just a test day, all right? Now, I may not allow you the full 2 hours. So when I make the test, I'll see how long it is, and if it turns out that I feel like you should be able to do it in an hour and a half, then I'll tell you have an hour and a half, all right? But plan on being here and taking the test, and then you'll be free to leave. On Monday, we should have time to discuss the exam. All right. I also posted the solutions to the homework, and I sent an email to everybody about that. Anybody having any issues with, like, are they not matching up? Okay, if you go to the Canvas course under Files, you'll see all them. Who has had an opportunity to get to those? Anyone get to them? So they're there, you can see them. Yes?
One of mine didn't match up, and that was number 13.
After this one? The one you asked about? Okay, well, let's talk about 12 first. Okay, so I'm doing number 12 from proportions. If there are 95 male students for every 100 female students at Northwest Vista College, to the nearest 0.01%, what percent of the students are female? Okay, so there's 95 male students for every 100 female. Is that how you interpret that? I like pictures, okay? I'm a picture. They're not great pictures. These are the males. There's 95 of them. These are the females. There's 100, right? Now, it's not saying that there are 95 males and 100 females, and that's it, right? It's saying that's the proportion that we have, right? That is, for every 95 males, we have 100 females. So there's a little more females than males, yes? What is the question that's being asked? What percent of students are females? What percent of students are females? So what, did you try anything or?
Well, I wrote it like this, I'm trying to find females. And I read it over and then 0.1%.
Okay.
Equals 95 nurses or students.
And you had too many things you didn't know, right?
Yeah.
Okay. That would have been, that sounds like the right approach following what we did in class, yes? But here's the issue. If you were missing something, right? So let me try and make this problem maybe a little bit easier to deal with. And this is what I've tried to encourage you to do, is if you're confused, make the numbers something a little easier to work with. So let's just say, for the sake of making this easier, we say that for every 50 male students, there are 50 female students, right? That means there's equal number. Then what percent of the students are female? 50%. Now, where are you getting that from? It's just thought, just thinking about it. How many students would there be together here? 100? And 50 out of that 100 would be 50%. And that's the same thing you have to do over here. How many students proportionally would you have here? 100. You would have 195. So you have 195 students total, right? Proportionally speaking, there's not that many students. There may be more or less in this college, but and there are 100 females. Right? Over the total. Now that could be different, right? You could double these numbers or multiply them by a half or something like that. But that's the proportion we have. We have 100 females for every 195 students. Does that make sense? And then you just compute that. You divide 100 by 195. So 100 divided by 195, you should get 0.5128, something like that, right? But they ask you to round it to the nearest 0.1%. So if you convert this to a percentage, what is this? 51.28%, but they say round to the nearest 1/10 of a percent, which means I'm going to round this position. How do we round a position? we look to the number to the right of it. If it's 5 or more, this one goes up, right? If it's less than 5, this one stays. So we should round this to be what? Approximately 51.3%. And does that match what the answer is supposed to be? Or maybe? Yeah, okay. Does it make sense?
Yeah.
Does it make sense that if you have more females than males, then the percent of females should be bigger than 50%? Okay, what else?
The dog. There was like puppies and adult dogs.
Puppies and adult dogs. Animal shelter?
Because I got a different answer from her.
Okay, so let's see. Let me look at it. We'll go through it. Okay, at a certain animal shelter, the ratio of puppies to adult dogs is 7-4. Ratio, they're telling you this is a fraction already. 7 puppies for every 4 adult dogs, all right? This week, there are a total of 55 dogs in the shelter, right? There are 55 dogs total in the shelter. How many puppies are in the shelter this week? How many adult dogs are there? Okay, so what do you think?
I said that with finding how many puppies there were by doing,
Okay.
making the X puppy
Okay, so X puppies
over 50.
over 55 total dogs
And then
must be equal to
7 over
7 puppies over, now hold on, 55 total dogs, right? You're on the right track. This is the most critical part.
The 4 is going to go at the top and then the 7 at the
Okay,
bottom.
if you put 4 up here, this is adult
Okay, no.
dogs, right? This is total dogs.
So you add the puppies and the adults to get the total.
That's the key, right? The key to the problem is how many total dogs would you have here? 11, right? So you should have, wait, yeah, 11. Okay. 11 dogs, right? You should have 7 puppies per 11 dogs. So X puppies per 55 dogs. This ratio must stay equivalent. Understand that? So these problems are a little more than, they push a little bit further than what we did in class, which is the whole point of homework. And then you do your thing, right? How do we do this? Cancel the puppies? Cancel the total dogs? Notice that when we're canceling these, we can cancel them because there's the equal sign. When we're doing conversions, remember that we multiply and we want the top and bottom to cancel. Do not confuse the two. These are two different concepts. So I'm solving for x. I'm going to take x, and I'm just going to get rid of the 55 here by multiplying both sides by 55. So 7 over 11 times 55. And what is it?
35.
All of it together? 35. Puppies? So you should have 35 puppies, and since there's 55, you should have 20 adults. Make sense? Okay. All right, that's about 10 minutes, about as much time as I want to take. On 13, we can talk about that maybe afterward or something. All right, so we are going to continue with conversions now. So does everyone have their little cheat sheets from last time? And good. These little name things, they should help me. I know they're kind of childish, but got to do what you got to do. So we're going to continue. So I'm just going to start with the problem here. We're going to do 96 ounces is how many pounds? LB, pound. LB, sometimes you'll see LBS, pounds. And I was thinking about this. My dad was on his phone the other day, and we had to do a conversion for something. I don't remember what it was. And he just used his phone, right? And in the real world, that's probably what we would all do, right? Just go to, you just go to Google and type in 96 ounces to pounds, and it'll spit out the answer. We all understand that technology is there. But what we're trying to do is understand how this thing called dimensional analysis works, how you actually convert from one unit to another. So for this, we need to look on our little cheat sheet and see if there's any way that we can connect ounces and pounds. So is it here? 1 pound is 16 ounces, right? 1 pound is 16 ounces. So what I'll do, let's see, where did we end up last time? I think we stopped at that table back there. I don't remember. We'll just start here today. So who's up? Lena, Bianca, Rebecca, John, Paul. Help me out. Try and stay in line with what I did last time. Well, I'll help you start. How about this? Since this is like Thursday, we're all ready to check out and start the weekend, right? I'm going to do that. And now?
16 over 1.
16 what?
Ounces over 1 pound.
Okay, so let's see. 16 ounces over 1 pound. Now, what do y'all think? Switch? Why? The other way? Why? Because the units need to cancel, right? So you're on the right track as far as the correct conversion, but because we want the units to cancel, we're going to put what we want to get to up here, pounds, what we want to cancel, which are the ounces, and then we put the actual conversion like that. And now when you cancel out the ounces and multiply the numbers, 96 pounds over 16 ounces, so 96 divided by 16, 6, so 6 pounds. All right, that was just a warm-up, all right? Let's try. Did you all understand the square feet and all that stuff, the last problem that you did on your own? Were you all pretty comfortable with that? Or, let's do one more of these. 0.5 square feet to square inches. All right. We should do like a table name, right? Like y'all should all come up. Y'all think of it. Maybe we'll do it next time. Each table can come up with like a team name. Doesn't that sound like fun?
Sure.
And then you can put a little thing on there, and I can call on the team instead of on individuals. Like I said, we got to throw anything in here that can make this not math, right? All right. So let's go with Sean, Nautica, Daniela. Daniela. What should I write down first here?
0.5
Okay.
squared.
0.5 feet squared over 1. Good. Equals or times?
12 inches.
Okay, so you already looked and saw 12 inches is 1 foot, right? So we've got that off the table. So which goes where here?
12 inches.
12 inches squared on top.
12 inches squared on top?
Over 1 foot.
Is it 12 inches squared?
Oh, it's not.
It's just 12 inches is 1 foot, right?
Because you have to do it twice.
Yeah, and that's the key to this, is that you're going to have to do it twice to get the feet squared to cancel. Please just recognize that feet squared here, right? This really just means feet times feet. So you have 2 of them, so you need 2 feet down here to cancel out. So you've got to do the conversion factor twice. So I multiply by this again. that. And then you can put your equals once you get all your units to cancel. So feet squared. And notice also, when both the feet cancel, here's where you're going to get your inches squared from. Inches. So what does that turn out to be? 72 inches squared, or you can say square inches, either way. There you go. Good. All right. Moving along. 2.05 times 10 to the 5th power seconds equals how many years? Now this is more interesting. And we don't have anything on here that converts time, right? But fortunately, we all know time, right? We've been using it for a while now. So what do we want to get from? Seconds to years, right? Seconds to years. So start like we've always started. Let's see, Jennifer, did we already? No, you asked the question in the beginning of class, but so I'll let your table start me out here, whoever. Or you put AK and mom, so do you prefer mom?
That's what I'm called most of the time.
Okay, mom. You'll be the class mom. Okay.
That tends to happen.
Okay, you got to bring the cupcakes and stuff.
Okay, all right.
All right, so what do we start with? Just write it down, right? 2.05 times 10 to the 5th seconds over 1 times. Now, this is where things might get a little hairy. Do you know how many seconds are in a year? Okay, what do you know? There's 60 seconds in 1 minute. You know that, right? Hopefully. What else do you know? 60 minutes in 1 hour. 24 hours in 1 day. And 365 days. We could have done weeks. In what, 1 year? Now the reason I'm not doing weeks, is because it would have just added an additional conversion factor. We would have had gone 7 days per week, then 52 weeks per year. So we're all comfortable with that? Okay, here we go. What? Oh, okay. So where do we start? We need to get the seconds to cancel, right? Okay, so that means you need to come in here with something with seconds down here. I'm just going to put sec. What do we know about seconds? There's 60 seconds in 1 minute. That means I'm going to have minutes on top and 60 seconds down here in 1 minute, right? All right, so that's going to get my seconds to go away. But now I'm left with minutes. So I've got to get the minutes to go away. So my next conversion is what? Minutes and hours, right? So 1 hour over 60 minutes. And that will allow my minutes to cancel. But now I'm at hours. So 24 hours in 1 day. 1 day, 24 hours. I did that, right? Hours. Hours cancel. Now what? I'm almost there, right? I need days to cancel. 1 year up here. 365 days. All right. Days cancel, and I'm left with years. So what you need to do is look at this as one big operation. You're going to go everything across the top first, all the multiplication of the numbers. This times 1 times 1 times 1 times 1, so it's just going to stay 2.05 times 10 to the 5th over, and it's going to be years, over 60 times 60 times 24 times 365. Now you can write it the way it appears here, or you can write it in scientific notation. I'm going to do both. I'm getting 315,360,000. Anyone else get that? Okay, which is 31 million, something like that. Written in scientific notation, it would be, what, 3.1536 times 10 to the 7? So that's how many spaces it would be? 1, 2, 3, 4, 5, 6, 7. I won't count the commas this time. There we go. And so you can do that on your calculator. We did these problems in the very beginning of scientific notation, right? So what do you get? Anyone want to tell me what it is or what they get? No? Nobody wants to share? Oop. What do you got?
6.5 times
10 to the 11th? Something's wrong there.
Oh, wait.
Did you multiply?
No, I didn't.
I got
10 to the negative 3.
Okay. What'd you get, Sean? Try. Anyone else want to?
10 to the negative
What?
6.5
6.5 times 10 to the negative 3? Yes? I'll do it. That seems reasonable. Where's my little, there it is. 10 to the 5 divided by 3.1536. 7. Oh, who did the 11? Who gave me that? Okay, are you using this calculator? Okay, so what you have to do is you have to separate, you have to use parentheses. So look, this is mostly for people, and well, anyone who's trying to put it all in one line. If you're going to try and type all of this in at one time, here's the way you have to do it. You have to go 2.05 times 10 to the 5. You have to put that in parentheses, then divide by parentheses, and then this, 3.1536 times 10 to the 7. Here's why. You want to see why? Why you got the answer you got? This is correct. This should be correct, this answer. We'll talk about what that is in a second, but the reason why you have to put in parentheses in your calculator is because if you do not, right, do not, your calculator is going to work from left to right because all you have is multiplication and division. It's going to take this number times this number, then divide by this number, then multiply times this number. Instead, see, that 10 to the 7 is supposed to be dividing into it. So your calculator is going to mess that up. You understand?
Yeah, I got the right answer. It's not in scientific notation, so I kept thinking it was.
Oh yeah, so we're just going to move the decimal over. So which way do we move the decimal if there's a negative? Right? Left. Think about this. Negative exponents should give you small numbers. Positive exponents should give you big numbers. So to make this smaller, we have to go this way. So 1, 2, 3, like this. You should be getting 0.0065 years. So 2.05 times 10 to the 5th seems like a long time, but it's, in terms of years, it's not much. All right, let's try another one. Were there any questions? I think Google's much easier, don't you? All right, how about this one, 88 inches per second. Convert that into miles per, you want to do per hour? Let's do miles per hour. It's miles per day in here, but I'm going to do miles per hour. See, we always like to convert speeds into miles per hour because we all get a good idea, right? We all have a good idea of what miles per hour means, right? If I tell you that I'm about to run into that wall at 88 inches per second, do you have any idea if I'm going to hurt myself? You think I will? 88 inches per, do you think I'll die? No? Break anything? No? 88 inches per second. How fast is that? See, do you agree it's hard to get a good idea of what that speed is? If I tell you I'm going to hit a wall at 88 miles per hour, there's no question about what's happening, right? If I say I'm going to hit the wall at 8 miles per hour, you have a good idea of what that is also, right? So we all have, miles per hour is something we all have in our minds. So let's convert this over to miles per hour, inches per second. So this problem is different than what we've done before because you know how we've always done like whatever it is we're trying to convert over 1? Well, this time we're given 88 inches per means fraction, okay, per 1 second. So instead of having just 1 unit, inches, when we say inches per second, it's inches over second. And I want to convert that into what? At the end of it all, I want this to be converted to over here miles over hours. So you've got to get inches to turn into miles, and you've got to get seconds to turn into hours. We're going to need a series of conversion factors to make this happen. So what would you like to start with first? You want to do the inches to miles, or you want to do the seconds to hours? What's easier, do you think, for you right now? Either one? Let's pick one. You want to do the distance, or you want to do the time? You do distance first? Okay, so we got to know how to get from inches to miles. Is that on here at all? I don't see inches to miles. I see miles to feet. Do you see miles to feet? So let me write that down. This is just, keep in mind, this is what we're trying to get to. Miles per hour. What I know is that 1 mile equals 5,280 feet. Okay, that will get me from, that'll get me from miles to feet. I need to get from feet back to inches, right? So what do we know about feet? 1 foot is 12 inches, right? So I'm going to need these two conversion factors to get myself from inches over to miles. So let's see, let's go around. We've done, did we do the table already? Gerald? No?
Not today.
No, let's do it. What do you want to start with here? Whoever at that table. Anyone? 12 inches on the bottom. Good. Good. 1 foot. Let's keep going. 5,280 feet. And on 1 mile. Does everyone follow what just happened? Yes? Okay, now we can start canceling the units just to give us peace of mind that we are getting things to cancel. And we've got to the mile, which is what we wanted. Now we're going to move on and take care of the time part, right? So let's move on to Carlos, Aspen, and you're back. Okay. So who wants to keep going with this over there? What are we working on? We're trying to get from what to what now? From Seconds, right? This seconds, we're trying to get it to hours. So, tell me about it. 60 seconds is what? 1 minute? And? 60 minutes in 1 hour. It doesn't matter how you write these. You could write 1 hour, 60 minutes, just as long as you have the relationship. I think that's all we need, right? We're going to get from seconds to hours this way. So sticking with this table, Aspen, do you want to give me a fraction here? You're trying to get rid of seconds, right?
So 60 seconds over.
Good. 60 seconds over 1 minute. Carlos? I'm going to defer to Carlos. Putting Carlos on the spot. We just got rid of the seconds. We want to get rid of minutes now. So what's the conversion that we have? Trying to get from the minutes to the hours.
Minutes to hours, well, there's 60 minutes in 1 hour.
Okay, so I'm going to do another fraction here. What goes on top, what goes on bottom?
60 minutes.
60 minutes over 1 hour. Yep, good. Now, if we did everything right, all the units should cancel, right? We should get minutes, minutes, seconds, seconds, the inches were gone, feet were gone. All we're left with is hours and miles. So our answer should be in miles per hour. So multiply all the numbers across the top. 88 times 1 times 1 times 60 times 60. I'm getting 316,800, and I'm going to divide that by 12 times 5280. So 63360, which is what is it? It's 5, what? Even? It's 5 flat? Now I'm going to write MPH because that's the way we like to write miles per hour, but do we all understand that that really means miles per hour, meaning a fraction? 5 miles per hour. I don't know, that probably hurt a little bit. I don't know. Walking is slower than that, right? I mean, right? Walking is a little slower. Depends on how fast you walk, I guess. But. All right. So there's a lot involved there, right? You ready to try one on your own? See if you can do this one. This one's going to be a tough one. 186,282 miles per second into meters per minute. That's going to be a huge number. You can use that if you want. So I'll help you just get started. You're going to have to go from miles to what? Meters. And you're going to have to go from seconds to minutes. Okay, enjoy. Y'all can work together, help each other out if you'd like. Get that team camaraderie going. kind of doing it up here as you're working. Got the conversion factors that you need, and then the work. Quick show of hands. Anyone else get this? Was that a question, or you agree?
Yeah, well, same. Well,
Yeah.
I did it a different way, got the same answer. I
Okay.
went from miles to feet.
Miles to feet, you can do that? Yep.
That's why at first I was kind of
Yep.
thrown off.
Yep.
But we got the same.
Yep. And that's a good thing about conversions. You know, whichever way you go, because you went miles to feet and then feet to meters. That's fine. I went miles to kilometers.
It kind of
Kilometers.
threw me off a little bit.
Yep. Yep. That'll work. Yes.
Goofy question. What does the E mean?
That means times 10 to the, and then that number.
Okay.
So do you have E10?
Yes.
That means times 10 to the 10. I knew someone's going to ask that. Anyone else have a calculator where it gave you like 1.79875 and then says E10? That E tells you this, and then the 10 is this number, not this number. All right, anyone have any questions on this one? We're all okay? Sure? All right. By the way, does anyone know this is a special speed, 186,282 miles per second. Speed of light. That's the speed of light. So think about that. It's moving. 186,000 miles per hour would be fast, but this is per second. Every second it goes that far. And we believe, at least all of our physics is based on the idea that nothing can travel faster than that speed. You've heard of Einstein's theory of relativity before? Heard of Einstein, I'm sure. Would you like a quick little intro to the theory of relativity? It's a real simple example. All right, let me see if I can make it make sense. All right, so let's just say I'm standing here. Here's me. And I have a ball. And I'm going to drop that ball. It's going to bounce, and it's going to come back up. Okay? So drop the ball, bounces, comes back up. Let's just say, for the sake of making this easy, that I dropped it from a height of 5 feet. And when it bounced back up, it came up to 3 feet. Okay, so I dropped it from 5 feet, went down, hit the ground, came up to 3 feet. And it did all of that in 1 second. All right? What was the speed of the ball? Average speed. How far did it go in 1 second?
8 feet.
It went 8 feet per second. Agreed? Do we all agree? This went 8 feet in 1 second. That was the speed of the ball. Can we all agree on that? Okay. Now imagine the same scenario, except this time there's a train track, and there's a car on the train track, right? And this is moving, and I'm standing inside the car with the same ball, and I do the same experiment. In fact, let's act like when you were watching this experiment, you were inside the car with me. All right? So this is what you saw, right? Dropped 5 feet, went up 3 feet in 1 second. Now, instead of being in the car with me, let's say you're outside the car and you're watching me go by. Yes? When I drop that ball, what are you going to see? It's going to fall, right? But I'm moving this way too. So when you see the ball drop, it's going to go like this, right? And I move too. And then the ball's going to come back up to 3 feet. It's going to be 3 feet high here. It would have dropped from 5 feet there. Yes? Do you agree? How far did the ball travel? Where's a red marker? You want to have a red marker? Where are they? Throw it. Oops. I was afraid it was going to go right in my Spurs cup. Okay. Good throw, bad catch. Okay, so it went here, and then it went here, right? All right, if you look at this, this is a right triangle right here. And we know that with all right triangles, the hypotenuse, right, is always longer than both of these sides. So this, no matter what, is bigger than 5, agreed? And then this hypotenuse of this right triangle is bigger than 3. So from the observer on the outside, it looks like the ball traveled further than 8 feet, right? In the same amount of time. So which is it? Did that ball travel 8 feet per second or more than 8 feet per second? That's the theory of relativity. It all depends on where you are in the universe, where your perspective is. Everything is based upon where you are. Like, am I moving right now? Technically? How? How am I moving? I might be like vibrating a little bit or something, but am I moving? We're on the Earth, right? The Earth's rotating, so we're moving. The Earth's going around the sun. We're going through our solar system, right? But it doesn't feel like I'm moving. So if you're standing here in this room with me, we're all moving together. It doesn't look like we're moving, right? But if you're standing on the moon, then you see these people spinning around in a classroom, right? So it's relative. It's all relative, and that's what the theory of relativity is about. In a nutshell, easy way to understand it, that's what it is about. So. All right, let's, sorry about that. The total amount of fresh water on Earth is estimated to be 3.73 times 10 to the 8 cubic kilometers. What is this in cubic meters? Cubic meters. What is this in liters? Everybody know what a kilometer is? Well, 1 kilometer is how many miles? 0.62. So a kilometer is more than half a mile, right? More than half a mile. So imagine you have a big block that's like half a mile wide by a half a mile tall, right? By a half a mile deep. Fill it with water. And then take that many of those. 3, 7, 3, move the decimal point 1, 2, 3, 4, 5, 6, 7, 8. 373 million? Take 373 million of those blocks, and that's how much fresh water we think we have on Earth. All right? How many liters is that? How many cubic meters is that? So let's start with the cubic meters. How are you going to go from kilometers cubed to meters cubed? What are you going to do there? I left off, we were here, we're up here. Caesar, Juliana, Shivani, and Alex. I already kind of set you up here. We're trying to do this one. Can you tell me what conversion factor you're going to use? Okay, 1 kilometer is what? 1,000 what? Meters? Is that what you said? Okay, so that's our conversion factor. Keep going. 3 of those, right? So how do I put it here? You said I need 3 of them. What goes on the bottom? What goes on the top? 1 kilometer on the bottom, 1,000 meters on the top. 1 kilometer on the bottom, 1,000 meters on the top. 1 kilometer on the bottom, 1,000 meters on the top. The number's only going to get bigger. I'm going to show you something real quick. Let's do our cancellation. Our kilometers go away, don't they? What's another way of writing 1,000? I can write that as 10 to what power? 10 to the 10 to the 2 is 100, right? 10 to the 3 is 1,000. This is another 10 to the 3, and this is another 10 to the 3. Do you agree with that? So if you really want to look at it, this is 3.73 times 10 to the 8th times 10 to the 3rd times 10 to the 3rd. Now the reason I'm writing it that way, missing one, sorry, 10 to the 3rd. The reason I'm writing it that way is because we can do this pretty easily by just using properties of exponents. Do you remember from exponents that if you have the same base and different powers in your multiplying, that you do what to the exponents? You add the exponents. So since these all have the same base, 10, 10, 10, 10, I can add up these numbers and I would get what?
17.
17? 10 to the 17. This is also in meters cubed. So this should be 3.73 times 10 to the 17. If you did that on your calculator, you should get the same thing. Do you? Did anyone do it on their calculator? And you got the same thing? Okay. So this is kind of a shortcut if you realize that 1,000 is 10 cubed. If not, you would have to just get on your calculator, do this times 1,000 times 1,000 times 1,000, and then put it in scientific notation. Questions? All right, what about the next one? Where are we? We've already done everyone? Right, we've gone around? So we'll start over. We're back on, do y'all have a name yet? No? Okay. Just erase that. I needed that. I want this to liters. So John Paul, Becca, Bianca. What are y'all thinking? Lena, any ideas? Are you all looking at it? Trying to figure out how to get from kilometers to liters? Wait a minute, hold on. This was not, was it? Hold on. Hold on a second. Yeah, kilometers to cubic meters to liters. So what are you thinking?
You have to get to milliliters, and then from milliliters you can get to liters.
From milliliters you can get to liters?
Isn't it like 2 separate equations?
Like in the style,
Yeah, like
yeah.
you have to do
Like
your,
how can you convert a liquid into liquid?
yeah.
I like.
Yeah,
Does chart work with volume?
that chart also works, yes?
So
But our basic thing is a meter, right? Right? That's our basic. So think about this. When you pour, if I had this box, right, that I'm going to fill up, and let's say it was 1 foot by 1 foot by 1 foot, then this would be 1 cubic foot, wouldn't it be? 1 times 1 times 1, that'd be 1 cubic foot. I could pour stuff into this, right? Gallons-wise, you could measure it in gallons, how much I could pour into this. Now, if this is a meter times a meter times a meter, then I can still do it, right? If it's kilometer, 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 I can still do it. There's a certain number of gallons, liters, ounces that would go into that. Somehow, we need to get from kilometers to liters.
Could you do 1 milliliter equals 1 centimeter? And then do
Wait, 1 milliliter is equal to what?
1 centimeter at the very bottom.
Yes. Okay. Does everyone see that? 1 milliliter is 1 centimeter cubed. Do you all see that there? Okay, but then what are you going to do for milliliters?
So milliliters
To liters. Okay. So do y'all see it? You have to like find it on here. It's kind of a pain, but that's why I'm allowing you to have this on the test, right? So that's the correct conversion factor. What I just wrote here was just to try and convince you that you can do this. You can go from kilometers cubed to liters. It makes sense. So using the fact that 1 milliliter equals 1 centimeter cubed, and then what else did you want to go and do from here?
milliliters of liters.
Is that 1 liter is 1,000 milliliters. So I'm going to be able to get from liters to milliliters and milliliters to centimeters cubed, but